What's going on, friends? Another day, another dollar. So today's job is a very simple one, but I'm gonna make good money off of it. So I just got a call from some guy that owns a ranch. Here in Texas, we got ranches all over the damn place. So this guy's selling his ranch, somebody else is buying it, and there was an inspection report. And the only thing for the entire ranch was at one of the buildings, there's no dead front on the panel. And the guy that's buying the ranch is like, it's a super serious problem. This has to happen. And the guy that's selling it is like, man, if this kid that's buying his ranch thinks that that's a big problem, he's in a world of hurt when he realizes that this is a ranch. You know, like, that means some things. Basically, ranches are just rough places. They're out in the middle of fuck all nowhere. There's usually no codes for anything. Most of the stuff on ranches are just done by the people that live on them. So like, for the whole thing, for the dead front to be missing, I get it. Like, I'm not going to sit here as a master electrician and tell people it's okay to not have dead fronts on your panels. You need to have them. Somebody can get shocked, but it's just kind of one of those things that, like, ranchers or like Texas boys look at each other and like this is a big problem. Every ranch in the world, I bet. Every ranch in Texas is missing. Some of them have panels laying on the fucking ground, like, whatever. It still works. Tie a rope to it, get our cattle to pull it up. We're good to go. So anyways, I'm out here. And he was like, I need this. This is a priority. I need this right now. We're trying to close in 2 weeks, so I need you out there today. And I'm like, well, it's an old panel. The likelihood of me finding this dead front is gonna be pretty slim, finding it right now. But I was like, if you want to pay my emergency rate, for me to go out there right this second, I will. And he's like, I don't give a shit what it costs. Just go out there. So I'm like, bet. So this is it. The first thing that I had to do was try to find a dead front. So, like, I'm way out in the middle of nowhere, just making calls to the local supply houses. There's not very many to choose from. And for those of you that don't know this, most supply houses specialize in like a specific brand because they work out deals a lot to get better pricing, but they a lot of times have non-competes, so they can't have multiple different brands to get better pricing. So it's silly, I know, but like some of them will be just a Square D distributor, and some of them will just be, like GE or Eaton or something like that. So I called around 45 minutes in every single direction, didn't matter. There were 3 supply houses that I could have chose, but I did find one that was Siemens. Then I asked for the dimensions, if they had a panel that was anywhere near like remotely the same size. And they didn't. Like, everything was either a little bit bigger, a little bit smaller. So there's just no way that I was going to get a dead front. So I called the owner and I said, look, the only option if I have to fix this today is I need to go buy another panel and put a different panel in and redo this entire service. And I'm going to have to call the power company, make sure they're cool with me disconnecting power. And he's like, just do whatever you have to do. So this is me doing what I have to do. Typically, as an electrician, you're not going to be taking out meters or putting meters in. That's usually the utility company's property. It's the utility company's liability, and they're the ones that do it. But in this instance, I did call and I asked, and they were fine with it. They're like, you're a master electrician. You're taking on the liability for this, so we're comfortable with it. That's fine. So what I think is really important when you're taking out a meter, if you do have to do this, is making sure that the load is off. Don't ever disconnect a meter when all of the breakers are still on. So if you ever like disconnecting wires, like, I don't know, so you're at like a switch and the lights are on in the room and you forget to shut a switch off, and for some reason you're working on this thing live, which you probably shouldn't be doing, but you say you are, that moment when you disconnect joints where the wires will spark, right? Because there's a load on. That's why that huge, like, you keep touching them together. That's why that's happening, is because there's actually a load on and it's connecting it. So when you shut the light off and touch those together, you don't have that same thing. Well, imagine that we're not talking like a 15 amp circuit, but imagine we're talking about a 100 amp panel or 200 amp panel doing the same thing, trying to connect or disconnect. That could be a huge discharge or a big arc. So make sure that you turn off the main disconnect so the premises is not under load. Now, if you notice, this panel is unique in that it has lugs in the bottom of it and in the top. So a lot of times when you're messing around with panels, the breakers are on the main bus bars, right? So you got your conductors that leave the sides and kind of go wherever they go. It's not often that you have a panel where there's huge lugs on the bottom where you have these huge conductors going in the bottom. They call this a feed-through panel. And it's specifically designed so that it can be used as a main disconnect at a service. Or if you want to be able to, at the main disconnect outside wherever your service is, if you want that one handle to be able to de-energize that panel as well as another panel down the line, you can have a common means of disconnection. So they used a feed-through panel in this instance because they needed some kind of main disconnect, but they also wanted the ability to have some circuits nearby. The other alternative is just to have put a main disconnect switch and not have any room for breakers. So it's just another method of doing it, but I thought that was interesting because a lot of people don't know what a feed-through panel is. So check this out. You want to see Texas? These are nails. This thing is just nailed in place. 2 nails. Send it. Now to my benefit, it's a little bit of a saving grace here, is that the electricians that installed this, or the farmer or whoever, didn't glue any of the PVC. So I had the flexibility basically to twist that 90 and take everything apart as I needed to. The actual male adapter where it was attached to the panel, that was glued, but down in the ground where the 90 was and where the couplings were, none of that was actually glued. So taking a panel apart when you have conductors coming in the top and it's fixed in position and you've got conductors that are leaving the bottom, oftentimes it sucks because you need to like lift one up and you've got all these thick conductors coming from the top and the bottom. So just trying to get this panel out of there is a really big pain in the butt. So it was a huge saving grace that I could just kind of kick this PVC over a little bit and twist everything and get it out. And then when I put it all back together, I could do the same thing. So if you can see, same panel, 8 spaces, feed through, 200 amps, just a smaller, much smaller panel. Siemens 8 space, 16 circuit, 200 amp. On this Siemens panel, the cool thing is that it actually comes with ground buses, like some brands, Schneider, Square D. For some fucking reason, we get your panels and you don't put ground bars in them. Like, that's the stupidest shit ever. I have to go to the supply house if I forgot, or if a customer bought a panel or something, they're not going to know to get the fucking ground bus. So you got to go make a trip, go back just to get the ground bus, something that should come in the panel, and most brands do. All right. We got to knock a 2-inch on the top. When you're doing this, be careful not to put the wrong knockouts out, and then you end up pulling too many out, because then you got to go to the supply house and get a reducing washer. Call it 5 3/8. Now, a little bit of a pro tip when you're working with PVC, one thing I recommend is making sure that you glue both sides. So when you put 2 pieces of PVC conduit together, don't just glue one side and then shove the other, end of it on, because oftentimes you'll just push that glue away. So if you glue both sides and you goop it on, like glue the hell out of it. If you glue both sides and you shove them together, you're still kind of just pushing that stuff, but you have a little bit better chance of still getting glue on both sides. That glue starts to dry pretty fast, so a lot of it does stay on that inner edge when you start pushing them together. One thing that used to confuse me when I was a young lad coming up through the trades is, what is a feeder and what is a service entrance conductor? What's the difference between them? Because a lot of times you'll see in the code book, feeders and service entrance conductors, they're like side by side in a lot of parts of code, or like something that will apply to a feeder will also apply to a service entrance conductor. So I was like, what is that? So I figured we should go through, open up your code books. Please open up your code books. If you're watching this anyways, just open up the code books. I'll actually teach you some things. All right, if you go into Chapter 1, Article 100, where all the definitions are, we have the definition of feeder. And for a feeder, it says all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit overcurrent device. So that means that any conductors that are from the service, not the meter, in code it also defines that the service is not the meter, the service is the main disconnect, the first disconnecting means of a premises wiring system. So from that first disconnecting means, leaving there and going to, let's say, like another panel, and going to a main breaker inside of that panel. That whole thing is a feeder. It's feeding something. It's not entering the service. So a service entrance conductor, I bet it has something to do with entering the service. We have two different definitions. One is overhead and one is underground because there's two different types of electrical services. So let's just read the overhead. The service conductors between the terminals of the service equipment, where we were just talking about that main disconnect, and a point usually outside of the building, clear of building walls, where joined by tap or spliced to the service drop or overhead service conductors. So basically, if you look at the main service disconnecting means, the stuff coming into the service from the utility, that's your service entrance conductors. The stuff leaving the service, leaving that main disconnect, going to another thing, another load, that is a feeder. But it's usually between a breaker and another breaker. So if you have, say, like a transformer, right, where we've got feeders that leave that main disconnect and they go into another disconnect, and then they go down into a transformer, and then they leave the transformer and they go over to another panel, to the main breaker of that panel, that all of that is still a feeder. The whole thing through the transformer, everything, they're still considered feeders. So it's kind of a weird word, and that's why it's a little bit ambiguous with the definition. But just remember that you're talking about anything prior to the main disconnect or after the main disconnect. Now I have to put the panel back on the pole, and again, I'm utilizing the fact that none of this stuff is glued, which is a huge saving grace. I do go back and glue it once I get everything in place, but just trying to feed the bottom and the top. You'll notice I have the panel at like a weird 45-degree angle and trying to just finagle all of it together. And then once I get it back in place, it kind of just snaps all in place beautifully. Boom! There we go. Before I strap this whole thing down, just gonna get my lock ring on, and the bushing on. A lot of times you'll forget to put the bushing on and you get everything all made back up, and then you're like, oh shit, and you gotta take it all back apart. You don't ever wanna go too tight with your lock rings or else you'll strip the threading out. All right. All right, trivia time. Do we always have to use plastic threaded bushings on our conduits? Aha! Should you is different than what does it say in electrical code. There actually is a difference. What I want to know is, do you think that it's based off of the conduit size? Like, 3-inch we have to, but 1-inch we don't have to? Or do you think it's conductor size? So like number 6 conductors, don't have to worry about it. If they're like 2-aught conductors, we do have to worry about it. And whatever your answer is, make sure you write the code article. Don't just say your answer because you think you know it. Put where it is in the code book. Cite your sources. Don't just say some shit. Put your code in your answer. Actually open your book and present an educated, intelligible argument. All right. Now, I got some Who-Daddy screws. Never used Who-Daddy screws before. These are Who-Daddy screws. Because Who-Daddy, they're long. I guess, wait, if that's long, I don't have a very good gauge of what's long. They're like 2.5 inches though, Who-Daddy screws. Who-Daddy! Oh, Who-Daddy screws. Put the trusty old level on there. all know that I used to fly airplanes when I went to college, Arizona State. They have a program at one of their campuses where you could learn how to be a professional pilot. Though I don't think that I became professional. I was a very unprofessional pilot. I flew planes. It was cool. Like at first it was really cool. But after a while, man, seriously, I just got bored with it. I was like, this is not as like fun. I'm not just free to fly the skies wherever I want. There's like a lot of like bureaucracy and shit that goes along with it. Oh man, Siemens, you're my dog. All of their screws are slightly unscrewed. So I can just stick the wires right in there. Love it. Do we always have to use plastic threaded bushings on our conduits? All right, so the answer to our trivia time is found in 300.4 in the National Electrical Code. We're looking in the 2020 protection against physical damage. 300.4G fittings. It says where raceways contain 4 AWG or larger insulated circuit conductors, and these conductors enter a cabinet, a box, an enclosure, or a raceway, the conductors shall be protected in accordance with any of the following means. 1. An identified fitting providing a smooth, rounded, insulating surface, like a threaded plastic bushing. A listed metal fitting that has smoothly rounded edges. That's number 2. Number 3. Separation from the fitting or raceway using an identified insulating material that is securely fastened in place. Number 4, threaded hubs or bosses that are an integral part of the cabinet, box, enclosure, or raceway, providing a smoothly rounded or flared entry for conductors. And the last paragraph says, conduit bushings constructed wholly of insulating material shall not be used to secure a fitting or raceway, meaning you need to still put a lock ring on. You can't just use the bushing. I've seen that a lot, like a lot of these older 70s homes and buildings. They'll just run the conduit in and put a little plastic bushing on. Come on, bro. The insulating fitting or insulating material shall have a temperature rating not less than the insulation temperature rating of the installed conductors. That's one thing a lot of people don't know, that the bushing itself needs to be at the same temperature rating, at least as the conductor's insulation rating. All right. It is the conductor size, has nothing to do with conduit size. Some people will run around saying, well, for 1/2 inch and 3/4 conduit, you don't have to really worry about it. That's not what it is. It's conductor size. The amount of current, fault current possible on the conductors. Huge conductors can have a lot of fault current, big old booms. So typically with bigger conduits, that's why on bigger conduits we have the threaded bushings. All right, well, that's it. This thing on there. We got 248 hot to hot. Red phase or phase B to neutral, we've got 124. Phase A or black to neutral, we've got 124. Ground, we got 124, hot to neutral, ground, hot to neutral, and neutral to ground, 0 volts. Turn the breaker on. Power should feed through now. We should have 248 hot to hot, 120 hot to neutral, 120 hot to neutral, neutral to ground, 0, hot to ground, 120, hot to ground, 120. Boom, daddy. All we got to do is put this thing back together. This thing. All right, let's go home, fellas and ladies. That is our final product. Isn't that neat? Isn't that neat? That's pretty neat. Love you, crazy people. Bye. Hey, before you go, make sure that you subscribe. Helps a brother out. Don't watch all these all the time, sit up here with my pretty face, and don't give me that subby. I'm all about them subbies. Also, please join the channel. Helps me out as well. If you want to contribute to what we're doing, if you want to support the channel, we've got 3 different tiers of membership. You can get your name up on the fancy screen, or you can get my phone number. Text me all your crazy electrical questions. Make sure you hit the thumbs up. Make sure that you hit the notification bell. Love you crazy people, and I'll see you in the next one.
Best music and video.